sizes with the frequency numbers, remember I said that because this group is so much bigger, this frequency, although it's lower than, let's say, 13, it will look sort of more imposing on the chart, won't it? It'll kind of take over a bit of space. And we don't want it to do that because, obviously, if you have a bigger group, you're likely to have more in it. But each thing in a bigger group should have less impact. All right? So, just like before, if we had two different sizes of groups that we were comparing, we would do relative frequency. What's the normal relative frequency we use day to day? Percentage, good. We compare test results and things with percentages. But you don't have to write a percentage as a percentage, you can write it as just a decimal, okay? 0.01 is 1%. So you were doing that on your charts the other day. This one, well, we do frequency density, so what does that mean? Area, yeah? And why that word density? What does it mean to us? When something has a higher density, what's it suggesting?
How much of it?
Sorry, Ollie had his hand up.
How much of it in a certain area?
Okay, so if it's a higher density, that means there's more in a smaller area. A denser material will have more mass in a smaller object. Okay. So in our situation, if we have a smaller group, right, if we look at frequency in a smaller group, you will have a higher density of information. Therefore, the frequency density here is higher. And if you look at the 9 people but in a group of 15, the density is only 0.6. Whereas 22 people in a group of 5 is 4.4. All right? So the good ones here, look, these comparisons, this group is twice the size, but frequency is almost the same. So you can see how frequency density is less than half of that. Right? So if I just did frequency on the chart, these two bars would be about the same height, but this one would be twice as wide and just look dominant on the page. Whereas when I do frequency density, this number is now going to be much higher. So I can plot that one. So if I plot frequency density on the y-axis and the age, the intervals on the x-axis, how do I know frequency from the charts? Someone's already said it today. So what we did, look, we did plot this information. So here's my histogram now with that, with frequency density plotted. Run that battery. How do I know frequency from this chart? This is the fundamental thing. This is the thing you all have to know, otherwise you're going to get questions wrong. Go. Now, how do I work out the actual frequency? So, for instance, this bar here, all right, this bar has a width of 10 and a frequency density of 2. But how would I know how many people or what's the frequency that was in there today? 10 times 2. So you're working out the area. So the area of the bar gives you the frequency. Right? So when we actually worked out this, that's how we did it, didn't we? So we said, how do I work out what the frequency density number is? Well, we know the width, the interval width. We know what the frequency is. So here's the frequency number there. 10 times, that's the width, something equals 20. So just a little bit of calculation. 20 divided by 10 gave me the 2. Are we a bit warm in here, brother? Do you want to switch the AC on? All right. So that sums it up. That's why we do it, how we do it, and what it looks like. So you can see now, look, here's a prime example. This bar is the one that catches your eye. This bar, look, the frequency is 20. This frequency is only 22. All right, only slightly higher, but look at the difference in the bar. All right, it's much more impactful because when we look at these charts, we look at the height. We don't necessarily look at the width. We just look at the height. All right, and this one down here, look, is 9 people, big wide bar, but not very high because the frequency density is quite low. All right, we'll remember that. All good? From yesterday. All right, now I wanted to just talk a couple of things, which is to work out an estimate for the number of cars over 70 miles per hour. Okay. So first of all, let's go through this question so we've got the information. Anyone done this one already in their time estimate? Done it already? Done the table? Yeah. Cool. Right, so let's go straight into finding our frequency density. So we've got a width of 15, a width of 5, a width of 5, a width of 10, and a width of 15. So I was chatting with girls yesterday. How do we know we should do frequency density? The groups are different sizes, so we go straight for it. So, frequency density, Hannah, can you just build them off for me? 0.4. 0.4. 2. 2. 9.2. 9.2. 4.8. 4.8. 0. Can anyone verify one of those for me? Do a check. Check with your calculator. What calculation should she have done? Can we confirm it's correct? I believe you, Hannah, so you don't need to get in. I believe you're right, but I want someone else to check. How do we do it? I'm not asking you, Hannah. Someone else. Thank you. Ollie?
You take like the difference between the speed interval.
Yeah. So for instance, 0.4, how did Hannah find it? What did she do?
So you go 15 times the frequency density has to equal 6.
Yeah.
So then you just figure out what the frequency density
How?
Divide 15 by 6.
So 15 divided by 6.
I thought it was 6 divided by 15.
Huh?
Which is how they ended up with 4.
It does matter which way around, doesn't it? If I do 15 divided by 6 or 6 divided by 15, I get different answers. Which one is it? 6 divided by 15. Good. We do 6 divided by 15. The area of the bar divided by its width tells me its height. So 6 divided by 15, just do that on your little computers.
It's 0.4.
It is 0.4. So we've done a check of that one with her. The next one is 2, yeah, 10 divided by 5, no problem. 46 divided by 5, yeah, seems about right. 48 divided by 10, definitely 4.8. 6 divided by 15, well that's 0. We've checked that one already. So Hannah, well done, we agree with your work. Let's draw this histogram then. Can I say to you, I'm going to give you, I'm going to draw it myself, but you just get on with it, yeah? 3 minutes, you can draw this histogram. You've got those values written. We just need to make sure that we do the axes properly. So, what can we go up by? We've got to get up to 9.2, probably
Every 5 small squares is 1.
Every 5 small squares is 1. So this could be 2, 4, 6, 8, 10. That works. That seems to fit everything in. If every 5 squares is 1, what's 1 square? 1 square equals 0.2. 1/5, yeah. And then underneath, we need to go from 40 to 90. So how would that work? Probably start at the 40. We haven't got room for our squiggle, but does it go 40, 50,
Yeah.
60, 70, 80? Yeah. Remember I said because it's an exam paper, they normally set it up to be relatively easy. Okay. Got your grids. We should label our axes with frequency, density, and it is speed in multiple. I'm going to pause my. Should we talk this through then? So an estimate for the number of cars over 70 miles per hour. So it does make sense to put a line through our work at 70, right? Mark that off, and you'll notice that 70 goes halfway through this bar, yeah? So it does say work out an estimate, so we're going to have to make an assumption here. And the assumption you're going to make is half the bar is over 70. Therefore, if half the bar is half the.
It's the same on each side.
So the frequency,
Yeah.
half the frequency. So, and we add it onto this. So the frequency of this bar I wrote in just for ease is 6. Half of that bar we would say is 24. So 24 plus 6, 30. Again, why is it an estimate?
We don't know how many are.
Good. You don't actually know. We have to assume that everything. They might, all of those 48 cars might be in the 65 to 70 range, therefore none of them in that group could be above 70. We just don't know, and we don't need to worry about it. Alright, and then the second thing I wanted to do is, what about the median? We've done this lots of times, but you've probably forgotten. Or think you've forgotten, but as soon as someone tells you. Yes. Total frequency, which is 116. Okay? 116 plus 1 is 117. Divide by 2 is. What is it? 58.5. So what does that number tell me? This is where people, if you remember that, that's great. If you remember, we've now got to remember how to interpret that number. Why?
Because it's in between 55.
Okay. No. Sorry. Sam. Why? You're correct, and I know you know what you're talking about. I just need that explanation for those people that haven't quite got it. How have you interpreted the 58.5, Sam? It's the frequency, yeah? So we are looking for the 58th and the 59th numbers, yeah? And we will go in the middle of those two. Now, because we've got grouped stuff, we don't actually know what the 58th and 59th numbers are, but we do know which group they're in. So if we do our cumulative frequency, look, this is 6, plus 10 would be 16, so 16 numbers in that group, plus 46 would be 62. So if that's 16, this is 62, both of these numbers must fall in the 60 to 65 group. Okay? So we can work out our median. Alright. Remember doing that? Oh, come on, of course you remember. You're just claiming you don't. What about if I said to you, what's the mean speed? How would you work that out?
I would multiply.
Hang on, good. Let me. I'm not going to stop you too long. Let's go to, guys. Let's go to this table, and let's do table shows information about the weight of 60 pigs. Let's do the mean weight of the pigs, just so we've got a fresh table to work on. So if I said to you to do the mean of that data, that gives you a clue. We don't need the chart. So what would you do, Gordon?
I've lost it.
Okay.
Add up all the frequencies.
Okay, add up the frequencies, which is 9 plus 16 is 25, plus 50,
60.
60. So my total frequency is 60.
And divided by 4.
Definitely not. If I did 60 divided by 4, I haven't used weight at all. So how can I find the mean weight of a pig if I have not used the weight of a pig? All you've done is figured out what the amount of pigs there are divided by 4 is. So we've got to use the weights. Anyone remember how to do the estimating the mean? Sam? Why did you do that, Sam? You're correct. Why did you do it?
It's in the middle
Because
of both of the numbers.
yeah, because we don't know what the numbers are, and how do you find the mean?
The middle.
No, that was the median. We have
Most
to
common number.
what?
The most
No,
common.
no.
No, that's the mode, not the range. Gordon?
You have to multiply each.
But why? Before we get to that stage, what? How do I find the mean of any data set? I have to.
You have to find. I don't know how to.
Ollie was sort of correct when he said you add up some numbers and then he divided by 4. That's wrong, but it gives you a clue. Taylor. Yeah, so we add up all the weights and we divide by how many pigs there are. The problem which Sam has overcome is we don't know the weights. And Nick was reminding us, I remember he understood very well at the time. Because I don't know which weight they are, what do you choose to do?
Use the
Middle.
middle.
So what's the middle here? The midpoint of this group is?
70.
68.
Sure?
It would be 70. No, wait. No, it wouldn't.
No, it wouldn't.
67.5.
67.5? Is there any way that someone that relies on their calculator could work out what you do? Well, I know it's the difference of 15. So 15, if I split that by 2, I get 7.5. So if I do 60 plus 7.5, I get 67.5. The difference of this group is 10. 10 divided by 2 is 5. So add 5 on, I've got 80. Yeah? So the midpoint is 67.5. It's 80. This one is, so half is 5, 2.5, add on 2.5, it's 87.5. This group is 20 big. So 20 divided by 2 is 10, add 10 on to the 90, you get 100. So the midpoint of all the groups is 100. Now Gordon wants to tell us the next step, which he did.
I've forgotten it.
Sam? Yeah, so we assume that we've got 9 pigs that weigh 67.5. So to add up 9 lots of 67.5, you multiply, right? 67.5, 16 lots of 80, 25 lots of 87.5, 10 lots of 100. You've got the calculator, I can do that one for you, that's 1,000. You do the rest. Okay, so we've multiplied, so we can add up those 9 pigs at that weight, 80 and so on, yeah, and then we add them up, get the total of all the pigs together, 5,075 kilograms. So imagine all the pigs have been put in one big pot, and then the weight is all spread out back to the pigs, so we then have a mean pig. So X bar I'm going to use, we do 5,075 divided by the number of pigs, and we get can't be 1,000. The biggest pig was 110. 84.58. So should we do 84.58 would be 84.6. Now that looks all right. It couldn't be over 1,000 because do you remember when you work out the mean must represent all the pigs. So the mean cannot be less than the minimum, and it cannot be more than the maximum. Taylor, do you remember what the name for the mean, the median, and mode was that you asked about yesterday? Yes, the mean is a measure of central tendency. So it should be somewhere around the middle. The median is definitely the middle. The mean should be somewhere around. So the mean, 84 point, it falls sort of just at the top end of that group. Does that make sense, looking at those numbers? Yep, not too bad. So that's the mean. So what have we covered today? Not just histograms. We've done some histograms, we've done relative frequency, we've done frequency density, we've revisited the median, we've looked at how you read from a histogram, the more than 70 miles per hour. We've redone a mean from grouped data now. Now don't forget, all of those things can be applied to stem and leaf diagrams as well. You can do it just from grouped data that is all the same group size. Doesn't change that, okay? So in terms of your, we haven't got an awful lot of time, but I think we did some better review there. In terms of your assessment, guys, the question was, what's the best way to review? Well, the best way to review is to use the textbook that I take all the questions from. All right? You are doing Unit 1. Okay. Unit 1 here. We've done 4.1, 4.2, and 6.2. So, table of contents. Pages, there you go. 4.1, page 82. 4.2, page 102. 6.2 was it? City Sky Histograms, page 189. Okay. Let me just point in. If you're on the computer, it's like 7 pages ahead. So I'm going to go to 100 and let's go to 196. Oh. City skylines. Just to remind you what we've done, what you should already know about continuous and discrete data. Right. Measures of central tendency. Right. From group tricks, so that came in 4.1 and 4.2. Know about qualitative and quantitative data. Know about that. So this is purely 6.2. This is the final topic in the unit. We've done bar charts and histograms. You've got the pink boxes here, which gives you some information. To finish, you remember doing a lot of this stuff, yeah? To finish off, right, there's some extra examples if you want to know a bit more. That's one thing we didn't look at, actually. Didn't do that for the last, we should just do that. The mode, do you remember what a modal class is? The class with the most in it, yeah? The group data. So what I will do, so one thing I was thinking about. if we go back to this graph, guys. Sorry, there's something we should add to your notes. Back to this graph. Which, for our frequency density stuff, which group is the mode? Or which is the modal class? Which one do you think? Which one would you choose? So maybe it's easier to see from the table. Which group is the modal class? Which class is the modal class? 60 to 65. 65%. Which one?
65%.
So we've got Ollie's opinion. Thanks, Joanne. No one else is speaking up. Anyone else have an opinion? Do you agree with Ollie? Yeah. Thank you, Nick. Hannah, what do you think?
So can the model class be in the same group as the median?
Oh yeah, that's not a problem. Never a problem. You would quite like that to happen, wouldn't you? If all your averages are around the same, that would make sense. Do we all agree then that the modal class is the 65 to 75 because it's got the most in it? Anyone else have any opinions they might like to share?
Do you take the relative frequency?
Well, this isn't relative,
I mean,
but what is the thing we did talk about when we started this question?
the most common.
Is it fair to have the group with the most amount in it be the biggest group, or is that kind of diluting things a little bit? Yeah? Do you really want a bigger group, potentially, size of 10, to have the size of the group impact whether it is an average or not? No. So actually, for frequency density data, the modal class for frequency density only is the one with the highest frequency density. And I'm sure you understand why. So in this case, all right, although this is the highest frequency, this here will be the modal class, but only because it's frequency density. All right, so if you're doing relative frequency, it's the group with the most in it. If you're doing normal frequency, it's the group with the most in it. If you're doing relative frequency, it's the group with the highest relative frequency. Okay? Alright. So, what are you going to study over the weekend? Well, sorry, I've just checked that. Have you written that in your notes, by the way? Have you added what you needed to your notes? Just pause the video